Hello everyone, welcome back. It's Mr. Baker here with our 10th installment in Honors Algebra 2. Today we're going to be looking at characteristics of parabolas and kind of review the first few days that we've been talking about as far as standard form, vertex form, whatever we need to do there. So we're going to add a few more pieces to the puzzle and you should be all experts in parabolas. Okay, so let's go ahead and get started. First thing we're going to look at is this function. Number 1, f of x equals x squared minus 6x plus 3. Okay. Now, let's go ahead and pretend like we're going to graph this, first of all, and then we'll answer all the questions that we need to answer moving forward. So, looking at this one, we need to find the axis of symmetry first. All right, remember that is negative b over 2a. All right, so what would that be? That would be a positive 6 over 2 times 1, which is 3. So, there's our axis of symmetry. We would do the vertex by plugging it back in. So 3 squared minus 6 times 3 plus 3. That's going to be 9 minus 18, which is negative 9. Negative 9 plus 3 is negative 6. So it looks like our vertex was 3 comma negative 6. Okay, so there's our vertex. And then also let's just go ahead and find the y-intercept too. It's because we're graphing this thing. Y-intercept is going to be 0 comma 3. So looking at the parabola now. On the graph, you have 1, 2, 3, 1, 2, 3, 4, 5, 6. We got 3, negative 6, and our y-intercept is 0, 3. Okay, so here's our parabola. We got our axis of symmetry right here. Awesome. We're mirroring it over that point. Great. This is all stuff we've done prior. All right, so here is what we've done. Let's add on to this. Okay. Let's first of all talk about domain. These are all blanks that you're going to have to answer when it comes test time, quiz time, you name it. So domain. First of all, domain is all about the x-axis. Or, it's really all about the x's. Okay, the x's. That's really what it's all about. So what you got to ask yourself is, well, does this graph, as it's going up, does it also go out on the x-axis? Sure. As this graph is going up, is it also going out on the x-axis to the left? Sure. So when you talk about domain, the domain, well, as this graph goes up, it goes out to negative infinity. As this graph goes up, it also goes out to positive infinity. So your domain, interval notation, working from left to right, we are looking at the domain being from negative infinity to positive infinity. All right, there's our domain. The range, again, you've probably seen this before. The range is really about the y-axis or the the y's. All right, so if I was looking at that, notice I like to use the pencil. For domain, we went from negative infinity to positive infinity because that's where the graph exists. As it goes up, it goes out. As it goes up, it goes out. Range is the y-axis. So notice I switched it to now the y-axis where I'm kind of going this way now. So where does this graph actually start on the y-axis? This graph actually starts on the y-axis right at negative 6. And then it goes where? It goes to infinity. So the range is from negative 6 to infinity. So range is from negative 6 to infinity. Well, you might ask yourself, all right, what do I put around these? Well, infinities always get parentheses because you can never equal infinity. But does the graph actually exist at negative 6? Like, is there a point there on the parabola that exists at negative 6? The answer is yes. So you're going to use brackets because brackets mean equal to. Okay, so we got domain, we got range. Let's talk about this fun thing called increasing and decreasing. Now, this sometimes takes kids a little bit, time to grasp it in your head. All right, increasing and decreasing is really I'm going to say it's on the x-axis. Okay, I'll try that this time. It's on the x-axis. What does that mean? What are you talking about, Mr. Baker? Okay. Well, as I'm coming in, you got to kind of imagine you're on this parabola. Like even when you graph this if you had a calculator, if you graph this in your calculator would start here, it would come down here, it would do this, and it would come back up, and you would have your parabola right there on your screen. If you don't believe me, let's go ahead and look at that real fast, just so you can see it. If I wanted to graph this parabola, I would have x squared minus 6x plus 3, and lo and behold, it comes from the top left part of the screen, it goes down, it goes back up. All right, so there's our graph. So you got to imagine, how does increasing and decreasing work? As I'm coming in here from the left, okay, what is this parabola doing? It is decreasing. So as I'm coming in from the left, Notice decreasing, it's still on the x-axis. So as I'm coming from the left, from negative infinity all the way to 3, because it's on the x-axis, all right? From negative infinity to 3, all right, this graph is going down, okay? As I'm coming in from the left, again, as I'm coming in from the left, this graph is going down. And where does it stop going down? It stops going down at x equals 3. Okay, now notice, on increasing and decreasing, I did not put a bracket. Because really, what happens down here at 3 is that the parabola, the slope of the tangent line to the curve is 0, so it's not decreasing anymore. So you can't actually equal 3. That's why we use parentheses. Okay. Now what happens as soon as you leave 3 on the x-axis? As soon as you start leaving this way, and you're still going left to right, as soon as you leave 3, what does this graph start to do? It starts to go up. Okay. So increasing, well, where does this graph start to increase? It starts at 3 and goes to infinity. Notice increasing and decreasing are on the x-axis. My pen is always moving this way. It's on the x-axis. So I'm increasing from 3 to infinity. Okay? We'll do another one of those so you can kind of see how that works. Increasing, decreasing. Boom. Let's talk about end behavior. All right, so end behavior is pretty straightforward, I think. When you talk about end behavior, I'm really asking about the tails, the tails of the graph. In other words, you'll see the notation that looks like this. As x approaches negative infinity, f of x approaches blank. And you got to fill in the blank. All right? So this is how end behavior is always set up. And this is how you read it. Okay? This is kind of like the hands of the graph. In other words, as x approaches negative infinity, so as we go left on the x-axis, y approaches what? So as I'm going left, where is the y graph going? Where is the graph? This is kind of like the left hand of the graph. So where's this hand of the graph going? It's going up to positive infinity. In other words, does this graph open up? Yes. Well, that's the left hand, and where's the left hand going? It's going to positive infinity. As x approaches positive infinity, okay, so as x approaches positive infinity, as we go this way, where's the right hand of the graph going? Okay, where's this arrow going? Well, it's going up to positive infinity as well. So we'll do end behavior. It'll make a whole lot more sense when we start doing polynomials of higher order like cubes, fourths, fifths, and all that other fun stuff. But for now, you can essentially bet that, if the parabola opens up, both of these are going to be positive because the left side's going to positive infinity, the right side's going to positive infinity. Okay, so that's the characteristics of the parabola that we've added to the puzzle. Domain, range, increasing, decreasing, and end behavior. Okay, let's do another one of those. Alright, so example number 2. Let's do f of x equals negative 2x squared minus 4. Alright, so let's go and graph it like we've been doing. Axis of symmetry, again, is negative b over 2a, so that is equal to, Mr. Baker, there's no b. Well, if there's no b, what do you think it is? Well, it's 0. So by the time you do negative b over 2 times a, you're going to get 0. So your axis of symmetry is 0 in this case. Okay? Axis of symmetry is 0. When I plug that back in to find the vertex, plugging the 0 back in, you're going to get negative 2 times 0 squared minus 4, which is just negative 4. So my vertex is 0, negative 4. Now, it just so happens that our y-intercept is the exact same thing, because as soon as I plug in 0 for x, I'm also going to get 0, negative 4. So my vertex and y-intercept are the same. All right? But let's talk about this. What would this graph look like? This is where I probably want you to find the x-intercepts, but I'm not asking you to do that because you really don't need the x-intercepts to talk about the characteristics of the parabola that we're talking about today. So 1, 2, 3, 4, 0, negative 4 is the vertex. It's also the y-intercept. Which way does this parabola open? It opens down. So here's my parabola. Okay? We can answer all these questions. So let's talk about it. Domain. Domain, again, is on the x-axis. All right? It's the axis. As this graph is going down, Is it also going out to positive infinity? Yes. As this graph is going down, is it also going out to negative infinity? Yes. So, does this graph exist from negative infinity to positive infinity? Yes, it does. Let's talk about range. It's the y-axis. Okay, notice I'm not going left to right anymore. With range, I'm starting this way, and I'm going bottom to top. So range always starts from bottom to top. So where does this graph start? Well, this graph has already started. With these arrows pointing down, this graph has started at negative infinity. So as I'm going this way, I start at negative infinity, and where does this graph stop? Negative 4 on the y-axis, because it's all about the y-axis. So we start at negative infinity, and we stop at negative 4. And I put a bracket around that because we actually equal negative 4 right there. Okay? Let's do increasing and decreasing. Increasing, decreasing. All right, again, this is on the x-axis, on the x-axis, on the x-axis. That's how you need to think about writing your answer. So, where's my red pen? Here we go. As I'm coming in here from the left, all right, as my pen is coming in here from the left, what is the graph doing? It's going up. It's increasing. So, from negative infinity to 0, because what did I just tell you? It's on the x-axis. That's 0 on the x-axis. All right, so from negative infinity, right, negative infinity to 0 on the x-axis, this graph is going up. What happens as soon as you leave 0 and you keep on going to the right? Where is this graph going? Up. Now it's going down, meaning that it's decreasing. So from 0 on the x-axis to infinity, this graph is now going down, decreasing. Okay? Talking about end behavior. Again, so if we're doing end behavior, as x approaches negative infinity, f of x approaches what? And as x approaches positive infinity, f of x approaches what? All right, so when you see as x approaches negative infinity, it's kind of like, what's that left side of the graph doing? What is that? Where is that left hand going? Okay, this left hand is going down on the y-axis to negative infinity. That's really because it's opening down. Whereas the, as x approaches positive infinity, that's really the right side. Where's the right side of the graph going? Well, the right side of the graph is also going down, so negative infinity. All right? Good. Good. So that's just 2 examples right there of adding on a few things, right? Now, one other thing that I'll throw in there, just an example here for you to look at. We'll call this example 3. Is I might throw one more, wrench in there for you. So let's look at f of x equals x squared plus 4x minus 5. Okay? Let's go ahead and find the axis of symmetry. X equals negative b over 2a. So you get negative 4 over 2 times 1, which is negative 2. We find the vertex by plugging that back in. So we get negative 2 squared plus 4 times negative 2 minus 5. That's positive 4 minus 8. So that's negative 4, negative 9. So it looks like our vertex right there is at negative 9. Yep, that's right. So vertex is going to be at negative 2 comma negative 9. There's my vertex. And the y-intercept would be, when you plug in 0 for x, it's going to be 0 comma negative 5. Alright, now the little wrench that I'm going to throw in here that you already know how to do, or at least you should remember how to do it because we spent some time on it, what are the x-intercepts? Alright, what are the x-intercepts? Well, how do you find x-intercepts? The first thing you should do really is factor. Can I factor this? If you can't factor it, then you probably need to do completing the square quadratic formula, but I'm giving you problems that you can factor. Are there factors of 5 that subtract to 1? Sure, this would be x plus 5 and x minus 1. If I solve those for x, I'm going to get negative 5 and 1. Those are my x-intercepts. But how do you write the x-intercepts? You would write it as negative 5 comma 0. You have to use the correct notation if you want credit. Negative 5 comma 0. Notice the y is 0, and that's where it's crossing the x-axis, negative 5. And then 1 comma 0. So there are my x-intercepts. And if I wanted you to come over here and graph this, it should be like to the t perfect. Okay, we have vertex at -2, -9. I'm trying to make these spaced out evenly. 3, 4, 5, 6, 7, 8, 9. So there's my vertex. I got a y-intercept at 0, -5. So 1, 2, 3, 4, 5. It's crossing the y-axis there. If you wanted to mirror it over, you could. 1, 2, put a dot. So, all right, so we've mirrored the y-intercept. But let's go ahead and put in these x-intercepts too. I should have an x-intercept at -5, 0. And I should also have it at 1, 0. So notice we just added one more piece to the puzzle that makes our parabola just that much more perfect. So if I ask you to find the x-intercepts, make sure that you can factor the equation, set them equal to 0, and solve for x. Okay? There you go. That's today's lesson as far as characteristics of parabola. Hopefully you enjoyed it, and we will see you soon. Thank you very much.